Okay, let's take a look at problem 2. In lesson 6-3, you solve linear systems using elimination. The same technique can be applied to systems of linear and quadratic equations. So let's look at problem 2 using elimination. Recreation. Since opening day, attendance at pool A has increased steadily, while attendance at pool B just rose and then fell. Equations modeling the daily attendance Y at each pool are shown below, where X is the number of days since opening. On what days was the attendance the same at both pools? What was the attendance? Okay, so let's look at it. So they give us that the equation for pool A is y equals 28x plus 4, and for pool B, y equals negative x squared plus 39x plus 64. Now, elimination is just one way to solve it. We do not have to solve with elimination, but it is a technique that we can use. So if we're going to use elimination, we need to eliminate one of our variables. And so the variable that they decided to eliminate was the y variable. And so they changed everything in this for pool A to negative. So we have negative times everything here. And so my y's cancel out. I get 39 minus 28, which is 11. And I get 64 minus 4, which is 60. And so now I can solve this. This is a quadratic equation. And so the first thing that they did is I factored out the negative 1. So they changed all the signs. And that's going to change to a negative 11x and a negative 60. And so when I look at it, 60 factors of 60 are 4 and 15 of negative 60. One has to be negative so that they can add up to a negative 11. So that's going to be positive 4 and negative 15. And so when I solve for it, I get x equals negative 4 and x equals positive 15. So we can't have a negative amount of days, so we're going to eliminate that one. And, oops, I'm so sorry. So, that means I have x equals 15. To find out the number of people that attended, I have to plug this 15 back into my original equation. Does it matter which one I plug in? Absolutely not. So they did for both of them. As you can see, I would have just done one. So it says the pool has the same attendance on day 15 for 424 people. All right, so let's look at problem 2. Suppose the daily attendance y at pool A can be modeled by the equation y equals 36x plus 54. On what days was the attendance the same at both pools? What was the attendance? So I've written it here on my whiteboard, and I'm going to do elimination again. So we'll have, and I'll have y equals negative x squared plus 39x plus 64. For the second one, I'm just going to change all my signs. And so I get negative 36x minus 54. When I do that, my y is crossed out, and I'm left with 0 equals negative x squared plus 3x plus 10. So I'm going to change all my signs, and I get x squared minus 3x minus 10. And so when I look at my factors, two factors that I can use are 5 and 2. One has to be negative, so negative 5 plus 2 equals negative 3. So I get x minus 5 and x minus 2. Sorry, x plus 2. So I get x equal 5, all equal to 0, and x equals negative 2. I can cancel out. I can't have a negative 2 days. So now I need to take this and find out how many people came on that day. So does it matter which one I use? No. And like I said, I'm only going to use one of those. So I have y equals 36 times 5 plus 54. And let's use our calculator for that. So 36 times 5 plus 54, which is 234 people. So 234 people came after 5 days. They were the same amount. I hope that this helps.